Going live in 5, 4, 3. Ladies and gentlemen, barons and baronesses of the coding world, this is the Daily Code, episode 12, and I'm your host, Chris, or assertchris if you prefer. Today, we are going to change things up a bit. I had a very disappointing stream yesterday, and it was kind of frustrating, but I thought that we could do something I'm a little bit more familiar with today. So I mentioned maybe doing something like an authentication library in PHP, something that would play nicely with the WebSocket stuff we wanted to do and the React stuff that we had done. And a friend of mine, Kayla Daniels, a very good friend of mine, suggested that we write a PHP library or framework agnostic authentication library, which I thought was a really cool idea. I thought that it would allow me to do two things. The first is that it would give a good example for me to write test-driven development-based code on stream. So that's the first thing that I'm excited about. The second is that Kayla seems open to the idea of potentially doing, of making the library potentially handle scalar types as well as asynchronous resolve later values like promises, which is pretty awesome because it means we can use it in the normal non-evented context of applications that we just build every day. We can also use it in the context of Icicle or AMPHP or React. So I'm pretty keen to do that. Let's get to it. So the library that Kayla suggested we make is called Sesame, as in like Open Sesame. And so far, all that's in here is a license file and a README. There's literally nothing that's gone on here yet because it's a very new idea. And one of the libraries that we are both familiar with, but that is closely tied to a framework already, is the Laravel PHP auth library. So if we head over to Laravel, everything but the Laravel site, laravel.com, we can have a look at the auth library there. Now, I thought it might be a good place to start in terms of designing auth functionality, but try very intentionally to keep it away from depending on a framework, because that's the purpose of this library. So, I mean, we can look through here and we can see basic examples of how to use it. I think what's more interesting to me is that all of the Laravel PHP code, or the vast majority of it, is based on top of a library of interfaces. This Illuminate/contacts, it is a full library just of interfaces for a lot of the functionality of Laravel. So we can see this stuff for auth, which we'll look at, cache, config, database. Most of the code base of Laravel framework is mapped out in these interfaces. So this probably gives us more of a design feel to the code that's running in Laravel, more than what the documentation would anyway. But what I want to do is I want to start by just planning out a system and planning it out through the use of tests. So I've gone ahead and I have set up this composer.json file requiring PHP 5.5 or PHP 7 and greater. I'm not interested in supporting PHP 5.3 or PHP 5.4 because those are discontinued and poorly supported, but I am interested in supporting 5.5 and 5.6, which is why this is here, and 7 and up. This poses an interesting question because if we support PHP 7 and PHP 5 in the same library, well, how do we do that? Some people, when they make these kinds of libraries, they have different main versions targeting different types of PHP. So they'll have a PHP 5 less than PHP 7 major version, which just has the normal PHP 5.5 and above stuff. And they'll have a separate major version for PHP 7 and above. That is one way to do things. It gets kind of, well, I think that might get kind of messy when you consider things like just typing composer require from the command line, because then it's likely to take the largest major version, but that may not be supported by the version of PHP that you have. And when you say things like composer require and just the package name without a version, it doesn't check the rest of your dependencies. So it doesn't check that you don't have PHP 7 installed. It'll just error out. So that's one way of doing it, two major versions for each sort of aspect of PHP, pre-7 and post-7. Another way of doing this kind of thing is to have both versions supported in the same major version, So to run code that's compatible with both in the same major version, but avoiding all PHP 7 and above features. Now, that's another way of doing things, but you don't get a lot of the benefits. So for instance, libraries like Icicle, where there have been improvements to PHP language from 7 and above for generators, Icicle has to have a separate branch because one of the main features of reactive architectures that Icicle facilitates is that they handle high concurrency. They need to be really fast, they need to be really efficient, more so than regular PHP, because they never unload. So when it gets to the improvements in PHP 7, it would be crazy not to use that. But at the same time, it would limit the scope of how people can use it significantly if it only supported PHP 7, like Eris does, for instance. So there are trade-offs to doing this kind of thing. If you want to support both in the same major version, you can do it by avoiding all PHP 7 features, but that's maybe not the best. Alternatively, an approach which I think might work is perhaps supporting both PHP 5 and PHP 7 in the same major version, but having different underlying class mechanisms that fulfill interfaces that are specific to PHP 5 or PHP 7. What I mean by that is having one interface that has no scalar type hinting and no return type hinting, and having another interface that is almost exactly the same method signature, but that has the scalar type hinting and the return type hinting, and loading them conditionally. That's interesting. That doesn't mean the underlying code needs to have scalar type hinting. The core functionality of the library, it could just support PHP 5.5, but the scalar type hinting is useful for validation for all external APIs. So maybe that'll work. Maybe. That's an option. For now, I think I want to do both versions supported in one major version. And for that to work, I'm going to have to avoid scalar type hinting for now, but I'll think of adding it later on as we improve things. So, how does authentication work in Laravel? Actually, I have a better place for us to start. Let's go and get a sample PHP unit config file. So, I'll just go to where I know a good one is. Something like this. Oh, not that. This file. Yes, okay. So here is a sample PHP unit file which I frequently use and copy from project to project. Not that that's ever caused any harm or anything. PHP unit XML. You can paste the stuff in here. Okay, so basically, when we run PHP unit, which is a unit testing framework for PHP, it has some default configuration, but more often than not, it looks for this configuration file, okay? That's an XML configuration file, as you've probably guessed already. And this already lists a lot of good defaults for how PHP unit needs to test. So it's things like not worrying about process isolation or not stopping on failure, all this kind of thing. Importantly, the bootstrap file that gets run should be the composer vendor autoloader file, because we want our tests to have access to all our classes lazy loaded. So this is an important directive for us to not forget. The other important things, well, we have a test suite we can set up. This goes into the tests directory, which we don't have yet, but it says that for every file that ends in test.php, run that as a unit test case. So we'll create our files in a similar structure to how we create the source files, but we'll just suffix them with test.php. We'll also create a base test class just called, I don't know, test case or test.php, but we'll make it abstract so that PHP unit doesn't try and execute it as a unit test, just as a way of centralizing some commonly used functionality. Also, while we're here, we've got this filter whitelist section. Now what this is used for is to check code coverage, and so if you're not interested in code coverage in your library, you probably don't need to add this thing in here, but this just says when you do code coverage, only check things within the source directory that end in .php. So what code coverage is as you run your tests, PHP unit also has a way of detecting which methods and which lines of code were executed. It does this by looking at using xdebug to look at each line of code that's executed. So it can tell you if there is code in your code base that isn't covered in a test. Now, why do you think that's useful? It's not to tell you how good your tests are. It will be an indication of how covered your code base is in tests, but it's a clear indication of what code is not covered in tests, what code's not executed. If you've got a lot of tests that test the main parts of your system, and you see there's code that's uncovered, you can look at that and you can decide at that point whether it's safe just to delete it. Would that work? Do you have to write tests to make sure that that code is used somewhere? It's pretty healthy to delete code from your code base if you can afford to, because the less code you have in there, the less code you have to maintain. So anyway, we'll look at that later. Test coverage. Now we need to make a test folder, so I'll just call this tests. And remember that base class I talked about, I'm going to call it testcase.php. So, okay, we'll create this with a namespace though, because that's what we want to do. For now, I'm just going to say the namespace is Sesame. We have ideas about what we want that main namespace to be later on, but I'm not going to spoil that surprise for you right now. Okay, so saying that the namespace is Sesame, something seems offish here with the stream. Are the audio levels fine? Someone say in chat if the audio levels are fine. Okay, so we'll use the namespace Sesame. For that, because we're not in the global namespace, we'll have to import the PHP unit test case class. So that's PHP unit framework test case. And then we'll create this class. So class test case extends this. Okay. We just want our classes to inherit from this because we're going to put some shared functionality in here later on for when we find things that we want to reuse in our classes. This is a good place to do that. Okay, let's also make a first test just to check that everything works here. So we'll call this example test. I actually want to rename this class to not test case, but test. Okay, example test. In fact, I'll copy a lot of this here as well. Okay, don't need that because we're just going to have example test extends test. Oh, I also need to remember to make this abstract because I don't want PHP unit to start trying to run it. Abstract class test. Okay, example test extends test, and we'll say public function test PHP unit works. I'm going to delete this like right away because I'm not really interested in keeping it around. But here I'll say this. So true, true. So this will pass. This will always pass. Okay. Now because we start our function names with test, PHP unit, when it reads this file in and when it creates an instance of this test case, it will see, oh, here's a public method that starts with test. I'll run this as a unit test. And there are other ways to note things that are unit tests without starting the function names with test. But it doesn't really matter. Test unit tests work. Okay, anyway, just remember, if it's a public function that starts with the word test, it's going to be run as a test case. And it's better just to remember that than to try and switch it off or to change that initially. Okay, let's check if this works. Because PHP unit's not going to read this in automatically because it's an abstract thing, I think it would be a good idea for us to auto-load this. So we'll do something like auto-load files, what did I call this? Tests, test.php. Okay, so that'll make sure that that abstract class is always loaded. And remember, because our PHP unit file has this bootstrap vendor autoload, that'll be run. Okay. Another thing we have to do, because we have these things, we have these classes in a namespace, is that we need to import those namespaces as well. Now we can use a number of different ways to do that. We can use a class map, we can load them as individual files like I'm doing here, but I want to add lots of tests, and I don't want to have to keep on adding them to some manifest. Test/test.php is an edge case, it's not the norm. So we can use PSR 0, I'm going to use PSR 4, it's an auto-loading standard, which you can Google, it's pretty common and it works very well with Composer. So how we do that is to say PSR 4, and then we specify namespaces and directories that files in those namespaces exist. So, for example, sesame, ending it with a backslash, and we say where that is. In fact, I'm going to give this a special namespace, which I'll explain on now. But I'll just say that anything in the sesame/test namespace is probably in this tests directory, so Composer can look there for it. Let's just roll that change out here. So sesame tests, test, sesame test. Okay, what did I call that? Yes, that's right. Okay, now because we've made changes to how Composer should autoload these classes, we have to update the autoloader. So we'll say Composer dump autoload. This generates a new class autoloader. If we go into this autoload file, we'll see this is unique. I think it will refresh if we dump autoload immediately. So does it refresh? Ends in F41. Does it refresh, or is it only when there's a change? I don't know. Anyway, you'll see here that it aliases another file. This file is automatically generated. The file that it references is automatically generated, and it loads a number of different autoloaders. So the ones that we've got something in here is to say, well, autoload files, hey, we specified that in Composer.json. Another is to say, okay, PSR4, hey, we specified this in Composer autoload as well. We have these other things here because they are dependencies that are already installed as part of PHP unit. Those dependencies have Composer.json files, and they also list these directories as PSR4 autoloadable. So that's why this automatically generated autoloader includes them as well. They're dependency autoloads. But this is one we've put in Composer.json. That's how it got there in the first place. Okay, where are we here? Let's close other tabs. Theoretically, this should work. I'm just going to see which PHP version I have installed here. So PHP 5.5. I also just want to install PHP 5.5 xdebug quickly. Unknown command. Install. We'll use xdebug for the code coverage. In fact, we have to have xdebug for the code coverage or it won't actually report that properly. But I don't want to forget to do it and then wonder why it's broken later on. Just do it now anyway. Okay, so using this PHP version, we can do something like php vendor bin PHP unit, because that file is present when you Composer require PHP unit. And then that should actually be all. Right, so it's picked up one test and one assertion. Let's make a change to that quickly just to see that this is still working. So assert false. This should break now, right? I mean, we'll have to give this a different name as well. This should break now because assert false true is going to break. So if we run that, hey, we have one pass and one failure. That's pretty cool. So we know it's executing this stuff. We can actually delete this file. Well, I'll leave it here for now. I'll leave it here for now, just as a template for future classes. But this is exciting. We're at the point where we can start writing tests, and it's tempting to think of test-driven development being all about having tests for all your code. But it's not just about that. That's a very good benefit. In fact, having tests for your code means you can be happy, confident that when you push your code to a production server, nothing's broken. When you make a big change, nothing's broken. But tests are actually more than that. In test-driven development, tests are a way to aid system design. They're a way to say, this is the functionality that my public API supports, and the code has to implement this. How it does that, well, that doesn't really matter. But as long as this public API is fulfilled, it's happy. So let's do something like that. Okay, so let's have a look at this authentication code. The main thing that we're looking for, in fact, I'm not even sure if I should have a look at this now, but the main thing that we're looking for is a way to abstract the process of authenticating users from anywhere. So this could be authenticating users that are stored in a database. This could be authenticating users over LDAP. This could be authenticating users from HT password. We can do abstractions that allow us to implement the concretions for all those different providers. And we're only really interested in testing the concretions if they adhere to the interface. So maybe a good place to start is deciding what that interface should be. Maybe that's a good idea. Let's do that. This isn't a typical part of TDD, by the way. And you'll notice a few differences in how I do TDD, perhaps from how you learn it elsewhere. I take a shortcut or two, which I think just saves a bit of time. But if you disagree, maybe speak up in chat or ask me on Twitter. That should be fine. Okay, so we want to have some interfaces for this. They're all going to be in the Sesame namespace, but we'll say something like Authenticator, just as like the very first point of entry to this. Okay, so namespace Sesame. And this is an interface, like a contract for things. Like that, okay. Now, probably the most basic method we want to have here is authenticate. And this can take, it can take a username and a password parameter. That's probably not as generic as we would like. We probably want to have something like just a plain old array. Credentials. And this lets us implement many different kinds of authentication. It allows us to do things like, if credentials has key and secret, try and use that to authenticate. If credentials has username and password, or email and password, try and use that. If credentials just has some kind of hash or secret token or something, try and use that. Array credentials allows us to almost overload things. So let's just use that for now. I won't worry about doing comments yet. But what are some of the concretions we can do with this? What are some of the concretions we can do with this? Maybe Authenticator, oops. Maybe we can do something like authenticate against HT password. Maybe something like that. Well, maybe we can even do something simpler. We can say, okay, our very first authenticator concretion is going to just accept an array of users. So an array of users with credentials that it can match. And it's going to have an authenticate method. And that authenticate method is going to look for email and password. Maybe that works. Okay. And the authenticator will have internal methods for doing hash resolution, that kind of thing. But we can do something simple. It'll be fun. Okay, so what should we call this? Array authenticator? Yeah, that seems okay. Let's make this a little bit bigger. Okay, so this is a class now, and it implements authenticator. We're going to increase this namespace a little bit, or nest this namespace. So I'll just do that now. This looks really confusing. I'm sorry if this looks very confusing. But it shouldn't be. Okay? This is a nested namespace, so because we've got this in a folder authenticator, the PSR4 autoloading is going to look for it in here. This says not use this namespace, but rather use the class within the root Sesame namespace called Authenticator. Or in this case, it's an interface. This looks kind of confusing, but they're referring to two different things. Okay, and this needs to be a thing. So I'll just say to do for now, because I'm not really interested in implementing this right now. What I do want to say is that, well, let's make a test for this. I want to keep parity between what my class structure is and what my interface structure is, so I'll make a folder here called Authenticator. And in here, I'll do array authenticator test. Okay. Now we can copy this example that we made earlier to check if the tests were working. We can say something like Sesame test array authenticator. And we can say that this is, oh wait, I don't need to do that. Sesame test authenticator, because Sesame test, remember, is this folder here. So authenticator is a level down, and then the class within that, array authenticator test. Again, we'll need to do this kind of thing. So not namespace, but use test/test, because that's the name of the abstract class, so that we can go extends tests. Now, what kinds of things do we want to test here? We have an interface with an authenticate method. We have one concretion example with an authenticate method because it implements the interface, but that doesn't do anything yet. What do we want it to do? Well, I think a good use case for this array authenticator, the way that I'm imagining that it can be used, is to have an instance of this array authenticator, to have an array of user credentials, as an example, to feed that array to the array authenticator, and then when you call the authenticate method, to have whatever credentials you send through matched against what's in the array. That could work. I think we'll leave the hashing out of this example class for now because I'm not really sure at this point the best way of going about doing that. But we've got a simple use case for this, right? So maybe what we want to do is, the first thing we want to do is, well, let's test if the array authenticator, oh, maybe we don't even need to be that explicit in this method name. Test user storage. Do we need to, as part of our public API, have a way to get the stored users out? Is that really necessary? Maybe we just treat this class as a black box and we put the users into it on construction and we never get them out. That the only method this has is authenticate. Maybe that's what we do. So perhaps we don't need to test for user storage. Perhaps all we need to test here is whether authentication works. Test authenticate method. Yes? Okay. Test authenticate. Now what do we want to test for here? We want to say something like authenticator is new array authenticator, and we want to feed it an array of users, right? Is everything working? Can everyone hear me? Everything going good? Everyone's so quiet. This is weird. Chat's very quiet. Okay, so let's do some example users. Let's say something like users is array, and we'll give a few users here, or just two, in fact. That's all I can be bothered to do now. So email, username, Chris, password, and let's make this interesting. I'll just generate a password. Nobody used that password. You totally could. It's uniquely generated. Okay, Kayla, and I'll generate another password for this. Okay, there we go. So 2 users and 2 passwords. As I said, we're not going to worry about the hashing right now. We're not really interested in that. But we can pass this array into here. Now, what are we interested in doing? Well, maybe we can create a credentials array. Maybe something like this, okay? And we'll say, we're going to test one user's authentication here. Maybe we'll test my user's authentication. So here, we'll repeat these credentials because we want to specify which is the username and which is the password. Again, we are not worried about the hashing between these. That's not part of what this class is supposed to do. Credentials. But what we want to test is that is this assert true authenticator authenticate. That seems like a reasonable thing to do. We have this authenticate method, so if we give it credentials and those credentials match something that we have in our array implementation, then we expect this to return true. We don't really care how it does that lookup. It'll probably be very easy to implement for this example. But we're only interested in whether the user successfully authenticates or not. How that's stored in session doesn't really matter. We can work on that kind of thing later, right? So this assert true, we also want to check whether we can determine false authentication. So how would we do this? Well, I mean, that's one thing that works. In fact, maybe we can just put this inline here. Maybe that's just as elegant. Okay, so we do that, and we know those credentials work, right? But if we do this and we change the user to Kayla, well, we expect this not to work because this isn't Kayla's password. It's this. So, let me just add some formatting here. So we expect this first one to return true once our implementation's done. We expect the second one to return false once our implementation's done. So this seems like a really good test. Let's run it, see what happens. Okay, we have a syntax error, line 28. That's right, I don't need a semicolon there. Run it again. Class, test, authenticator, array authenticator not found. Okay. So use this. In fact, I'll put this up a line above. And the class is array authenticator. Okay, what's the error now? Still not found. Sesame authenticator. Okay, so this exposes a problem that we have here. We've created the namespace stuff for the tests directory, and we've manually imported the abstract base test class. But what we haven't done is add the auto-loading for the main classes. We've just got the test stuff here. So it's easily remedied. We just reference the top namespace, because that's where all these classes live, and the source directory. And then the tests can live in a sub-namespace called Sesame Test. Remember, we need to compose a dump autoload for this. And now, let's see if we get a different error. Okay, so we have one failure here, and because that failure happens within this one test method, it doesn't try and do the second assertion, it just fails the test after the first assertion fails. But now we have something going on here, failed asserting that null is true. And this is the first thing that we can start to implement our concretion on. Okay, that's really cool. This also installed Xdebug, so when we need that later, we can go back to that. I think we're in a very good position here. I just quickly want to take a quick break and get some water, stretch my legs. So I'll be right back.